Hello, in this video, we're going to look at solving systems of inequalities, in particular, one that's linear and some that are nonlinear. A solution to a inequality is every point that satisfies that inequality. So when we consider systems of inequalities, the solution to such a systems is a set of points that makes both inequalities true. We can show this by shading and graphing. So that's what we'll do here. So first, we want to graph the system. We're going to graph these one at a time. And you'll want to notice that this is the form of a circle. Let's talk about that just real quick over on the side. We'll put it right here. So if an equation is in this form where it's squared and then plus, and then squared, and it's equal to a number like this is, it's a circle, and HK is the center, and then R is the radius. So this top equation here is a circle. It follows that pattern of x squared plus y squared is equal to r squared. And the center is 0, 0, because there is no number like inside the parentheses that would move the circle left, right, or up, down. So the center is 0, 0 because h is 0 and k is 0. There's nothing added or subtracted. And then the radius, you have to take the square root of 4. So you get a radius of 2. To graph this, what I usually do is just put a mark at the center, although that's not a point on the circle. So just kind of keep that in mind. But then just go out 2 every direction. So a radius of 2 means the circle hits here, 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 and here. And then just try to draw the best circle you can, although it does not have to be perfect. Okay, so we'll graph, and probably should mention this, but to graph these inequalities, or to solve these system of inequalities, we're going to graph each of these separately. So we'll graph and then also shade. We're going to wait to shade until after we get them both graphed. Now, you don't have to do that. If you want to shade now, you can. And maybe that's actually, let's do that. That might be a little simplify things a little bit. So to decide where to shade, we want to pick a test point. And for circles, you're either going to shade inside or outside of the circle. There is a shortcut, but let's look at a test point first. And so let's just pick anything. Let's put 0, 0. So let's test 0, 0. So that means x is 0 and y is 0. And you plug those in and you get 0 squared plus 0 squared is equal to less than or equal to 4. And is that true or false? So this is true, and we always shade where it's true. So shade where true. And if it's the x squared plus y squared is less than the radius, it's always going to be the numbers that are inside. And if it's greater than, it's going to be the numbers that are out, or the areas that is outside the circle. So let's shade this inside. We're just going to do that with a couple lines like this. And if you have like a pencil, that'd probably be better. Or if you're doing this like with a stylus, it's nice because you can kind of erase the shading as you go. Okay, so that's the first inequality. Now the second inequality is what is a line. So we have x minus y is greater than 0. And so we graph that by subtracting x and then dividing by -1. So we have to flip the inequality. So we have y is less than x. Okay, so that is a line with a slope of slope of +1 and a y-intercept of 0. So that will look like this. And then this is going to be, because it's less than, it's a dashed line. And then we can use a test point here, but if it's a line, y equals 0, like the shortcut, so y is less than x. So if you go to the y-intercept, then you shade below the line, because we want the values where y is less than that y-intercept. But if you wanted to plug in a test point, you could plug in something down here like 0, 1, and 1 is less than 0. Okay, so this actual solution is the overlap. It's where they're both true. So the solution is this area here, which we'll shade green. Okay, so we shade where it's true. Some other things to remember just when you're graphing inequalities. This goes back to when you, non-systems even, but if it's less than or greater than, use a dashed line. And if it's less than or equal to or greater than or equal to, it is a solid line. Okay, the other thing you might have to do with this is actually be asked to do is actually find where these intersect. Like where are these points that make it true? We call those the vertices of the system. And so if you want to find the vertices, then you have to solve the system. So to find vertices, which is where they intersect, the lines intersect, we solve the systems of equation. And I'm running out of room there. So to do that, we'll just use substitution. So if I know, I can write this as y is equal to x, and then I have my x squared plus y squared is equal to 4. If I treat it as an equation, then we can substitute either one, x or y is x. I'm going to say x squared plus x squared is equal to 4. So substitute x in for y. And that becomes 2x squared is equal to 4. Or x squared is equal to 2. And so x is equal to plus or minus the square root of 2 to get x by itself. Okay, so that gives me my two x values. So let's go ahead and write that in. Negative square root of 2 and positive square root of 2. And then to find y, I just plug that in and say, well, here's y is, I know this equation, y is equal to x. And so that means the x and y coordinates are going to be the same on each point. So this is what's called your vertice, what are called your vertices. And that's these 2 points where the line and circle in this case intersect. Okay, so if we have something like this, where there are 4 inequalities, it's still just where we're shading where it's all true. Now, in this case, I would recommend getting the lines on there and not completely shading, but kind of just marking, because some of it can just be confusing as to what's what and what's shading and everything else. One thing to note here is that they're all either less than or greater than, so it's all dashed lines. And then I'm going to solve these just one at a time. So we get y by itself by subtracting. Let's do this. Let's number them 1, 2, 3, 4. That might be a little neater. So 1 would be 2y is greater than 4. Whoops, 2y is greater than negative x plus 4. And so y is greater than negative 1/2 x plus 2. Number 2 would be y is less than x plus 1 when we add x to both sides. Number 3, let's see. Number 3 would be 3y is less than negative x plus 9. And so y is less than negative 1/3 x plus 3. And then number 4, we'll just keep as x is less than 3. Okay, and then we're going to graph these one at a time. So this has a y-intercept of 2, and we go down 1 over 2, and that is a dashed line. This blue line, number 2, has a y-intercept of 1, and we go up 1 over 1 for the slope, and it's also a dashed line. Number 3 has a y-intercept of 3, 1, 2, 3, and it goes down 1 over 3. Oh, 1, 2, 3. And then number 4 is x is less than 3. I remember lines that are in the form x is equal to a number are vertical lines, and that's going to go through here. Okay, so now we have to figure out where everything is graphed. Now, if you're doing work at like a textbook, a lot of time, or where everything's true, so we're going to shade. A lot of times you're probably looking for like an enclosed region, but not always. And let's just kind of take it one step at a time, or one equation at a time. And so I want y is greater than negative 1/2 x plus 2. So I go to that line, I say I'm going to shade above that line. So just kind of keep your pen or pencil above that line, so above that line. But then on the next one, I need to shade below x plus 1, so below the blue line. So I need above the black line, but below the blue line. So now I'm down here. I need to shade below the green line, which is this region right here. And then x is less than 3 would be to the left of the orange line. So it is, in fact, this region in the middle where they are all true. That does take some practice. Use some colors to help you, or some highlighters, maybe like colored pencils, or if you're doing work on a computer, like you have different colors, you can change your pen and ink, and then I would do that. But a lot of times, like I said, if you want to take the kind of shortcut, look for an enclosed region of everything, because a lot of times problems are written that way. But it doesn't have to be true. Like if this problem were, if I just change this to x is greater than 3, then I would shade this region over here. But so the shading represents all of my solutions. To find the vertices, you want to look at where each lines intersect. So if you want to find the vertices, you need to find, okay, well, here I need to find these two, and that's where x is going to be equal to 3 for the green and the black. So for the black, if I plug in 3, I get negative 3/2 plus 2, which is 0.5 for down here. And if I plug in 3 to the green, which would be this point, then I get negative 1 plus 3, which is 4. And you can kind of check that. Whoops, that wasn't right. Negative 1 plus 3 is 2. So that's a good example of why you should check your work with your graph to make sure it is correct. And you might be able to even just see, no, that's not the case for the other ones either. Okay, so then we need where this green hits the blue, and then where the green hits the black. So if I look at the green and the blue, I can set those equal to each other to find x. So that gives me x plus 1 is equal to negative 1/3 x plus 3. So if I add a third, that's 4/3 x is equal to, subtract 1, 2. and then multiply by 3 and divide by 4 gives me 6 over 4, or 3/2. So I'm doing the blue and the green. X is 3/2. And then to find y, I can plug it into here to get 5/2. So this is, and maybe we should write blue and green, so I know where that one came from. And then the blue and black is the last vertice. And I'm not going to try to put these, normally I could try to like put these all on the graph, but my graph's a little small. So the blue and black, I can set, once again, since I solved these all for y, I can just set them equal to each other. So x plus 1 is equal to negative 1/2 x plus 2. So I add 1/2, you get 3/2 x, subtract 1, you get 1, multiply by 2 and divide by 3, and x is 2/3. So that's 2/3, which looks about right. And then when I plug that into either one, if I just do 2/3 plus 1, that would be 5/3. So there's a lot to keep straight. So make sure you work carefully, make sure you check your work. But the shading, all the solutions are included in the shading, and then the intersections are, or the vertices are all listed there as well. Good luck, and reach out if you have questions.